So in this video, we're going to continue to look at arithmetic sequences, but now we're going to look at how to write not only the formula for it, which we kind of looked at in the previous video, but now we're going to look at it a little bit more, and we're also going to look at how to find the sum. So the sum of an arithmetic sequence means the sum or addition of the terms up to a specified term. So it'll tell you how far to go, the 100th term, and you want to add all of those together. What's the sum of all of those numbers in the sequence? While it's possible to compute such a sum by manually adding the individual terms, such an approach becomes infeasible, difficult, as n, the term number you're looking for, becomes large, right? So even if I asked you to go to the 100th term, well, that's a lot of terms. Not only do you have to know all of the terms, but you'd have to accurately add them all, which, the more manual calculations we're doing like that, the more likely it is that we will make a mistake. It's just human nature. It happens. Luckily, however, there is a simple formula for computing the sum, which is Sn of the first n terms of an arithmetic sequence. So you can see that down here. We have Sn, that's going to equal the term number, and we multiply that by the sum of the first term and the term number that we're going for. So if it's the 100th term, we do need to know what the 100th term is, and we need to know what the first term is, because we're going to add those two together, and then we'll multiply that by the term number we have and divide by 2, and that will tell us what the sum is. So this is the formula we're going to use. Now, because we need to know what the first term and whatever term number it is we're going for, we do need to use the arithmetic formula, because we may be given a few pieces, and then we're going to end up having to build a formula or use a formula to find these two pieces. All right, so let's go ahead and get started on that. So this is the problem that Alex will give us is something like this. It'll either give us the sequence, and we get to go through and build a formula. With this one, we don't actually have to build too much of the formula, because I can see the first term and I can see the last term. What I don't know in this sequence is what term number this is, because it just goes ... So I have no clue. I'd have to literally go through, find the pattern, and then figure out how many times did I do that to get here. So there's a little bit of an easier way to do that instead of going through and finding that piece, because I do need to know the term number for this one. The second one, we'll deal with this a little bit more on the next slide here when I go to the next page, because this is written in a very special notation. So don't worry about this one quite yet. We'll get there in just a minute. So first we need to find the term number n. Then we can find the sum. So use the arithmetic formula first. So we're just going to fill out what we do know. So I do know that the first term is 9. And the nth term, the term that I'm going for here, the very last one they gave me, is 306. So I do know those two pieces at least. And then the common difference, remember, that's what am I adding or subtracting? Okay, so to go from -9 to -6, well, that'd be I'm adding 3, right? I know they're both still negative, but I'm getting closer to 0 on this one. So I'm adding 3. I can also see I'm adding 3 again to go from -6 to -3. So that's my pattern. I'm adding 3 each time. And yes, I can manually do this and try to figure out how many times I would have to do that to get to 306. But we can also just use this formula here to figure out what n is. So if I plug in the numbers to what I have here, I have a1 and I have n, and I have a to the n. I know what term number I'm going for. I have everything except for n, right? So I can go ahead and fill this in down here. Sorry. So I have 306. That's my last term number. -9, that's my first term number. I don't know what n is, -1, and 3 is my common difference. So now I'm going to take that 3 and I'm going to distribute it because I want to get rid of these parentheses here. I could also divide by 3 on both sides, but I do need to make sure if I do the division method, 9 also gets divided. Everything gets divided, okay? Because -9 is a separate term from n-1, so I'd have to divide n-1 by 3 to get rid of this multiplication by 3, and I'd also have to divide 9 and 306, so just one of those pieces. Don't forget to divide everything if you choose to go that route. So with this one, I'm just going to distribute the 3, so I have 3n and then -3. All right, so now the parentheses don't really mean anything. I can actually just drop them and start combining like terms. So I have -9 and -3, so I'm going to go ahead and combine those to get -12, and then 3n just comes down. Now I can start to solve because I've simplified as much as I can. So I'm going to add 12 to both sides because I want to get n by itself here, right? That's my whole goal. So 306 plus 12 is 318. The 12s cancel and the 3n just comes down here. My last step to find out what n is here is to divide by 3 because I want to undo that multiplication. Right? I want to get n all by itself. So 318 divided by 3 gives me 106. So this is the 106th term. Okay, so I had to go through and get that before I could apply the sum formula that I have. So here's my sum formula. So now I can use the sum formula. Okay, so now I'm going to go for the 106th term, and I needed that. Remember, I need to know what term number I'm going for, not just what the term is, what the number is, because I know that's 306. I need to know what term number that was. So now I have my first term and the last term I'm going for there, and I'm going to divide all of that by 2. So 106, I'm going to add these together, because when I subtract 9, I get 297. I'm going to multiply on the top here. I'm going to get a nice big number for a moment, 31,482. And then when I divide by 2, I have 15,741. So this is the sum of the sequence up to term 106. So the sequence could theoretically continue. I don't see the ... so maybe it's cut off at that point. But this is the sum up to that number. So we can find the sum up to any term number we want to, as long as we have the pieces to plug in here. All right, so let's go ahead and take a look at the second piece here, because we have this fun notation. So this doesn't look like a sequence. The second problem is written in sigma notation. So this kind of backwards, it's not really backwards, it's just this kind of funny looking E, is a Greek symbol for sum. Okay, so the number at the top of the sum is the nth term. So you can see this is the term number I'm going for. And this is how it's always set up in sigma notation. So 81, that's my term number. The number below the sum is the term to start with. So sometimes we start with something other than 1, but usually we're going to start with 1. And the expression to the right of the sum is the rule of the sequence. So this gives me the equation to use, right? So that I'm going to need to find the first term, and I'm going to need to find the 81st term, because I need that to plug it into my formula. So that's the second piece we're going to look at here, now that we know how this is set up. So we're going to use the rule, excuse me, to find the value of the first and the nth term, and then use the sum formula to find the sum up to that nth term, which is 81. So 8 to the first power, I'm going to plug in 1 in my formula here, right? So this is my rule, 5k plus 3. So that's where this came from. 5 times 1, because my first k is 1, plus 3. So 5 times 1 is 5, plus 3 is 8. And then my last term, or the term I'm looking for the sum, is 81. So 5 times 81 is 504, plus 3 more is, 405, and then plus 3 more is 408. So now I have all the pieces I need. I know my term number, I know my first term, I know my last term. So I can go ahead and plug it in to my sum formula. So remember, my term number goes first, that's 81. And then I'm going to add my first and last terms together and divide all that by 2. So 8 plus 408, that's 416. Now I'm going to multiply by 81, and I get another nice big number here, 33,696. And I'm going to divide by 2 to get 6,848. All right, so this was using the sum formula with a sequence and using the sum formula with sigma notation. So I hope that helped, and I will see you in the next video.